Sanibonani, Dumelang, hello everyone. My name is Helen, but some of you may recognize me as Mama H. And you're welcome to call me Mama H or Helen, but I'm here to get you through a section on life sciences because that's the thing that I do. So what we're looking at in the next few lessons is the main topic, population ecology. And for today, we are going to be referring to changes in population size. So let's have a little bit of a reflection on what we mean by changes in population size. And let's consider this question. Have you ever thought about why overpopulation is a problem with the human population, but this doesn't seem to be a problem with our natural populations? What's the deal with natural populations? How can they seem to maintain their size? Are there things working behind the background? Yes, there are. And that is what we're going to focus on in today's lesson. But what I want to do is give you a huge mind map, a concept map that's going to show you about where we are going in this whole section. This section falls under the banner of environmental studies. Within environmental studies, we are covering the broad topic of population ecology. Our job in this lesson is to give you a brief introduction and to focus on population size. What do we mean by a population size, and does the size of the population, does it change or is it steady all the time, and what causes those changes? So that's where we're going in this lesson, and you've got more lessons to look forward to as we go further. The one thing that I do want to remind you of is that in a few lessons' time, we will look at human population. For now, I want you to put the idea of human population out of your head. Right? We're focusing on natural populations of plants, animals, bacteria, all sorts of living organisms, except humans. So this concept map narrows things down a little and simply focuses on what we're going to be doing in this lesson. So we're going to have a little bit of an introduction just to remind you of what you should be remembering from previous work that you've done on environmental studies, and then we're going to get into the subtopic of population size. We're going to be looking at three important aspects: parameters, fluctuations, and limiting factors. And I'm not going to explain them right now to you because that's what this entire lesson is about. So as we get to each one of those points, we'll unpack it, make you quite comfortable so that you know the difference between a parameter and a fluctuation. All right, so we're going to be building your vocab as we go. Now, talking about vocabulary, here is a list of keywords that you're going to see creeping up again and again throughout not only this lesson, but lessons to come. Now, my advice to you is to keep a glossary. Get hold of a little notebook, maybe one of those notebooks that is alphabetized or it has a little index. And when we get to one of these keywords, make sure you put the keyword in as well as the definition. Because you know that in those final exams and even in tests, you're going to see terminology and definitions, all of that coming up. And if you are spot on with that terminology, you've already scored points. So these are the terms you're going to encounter in this particular lesson. And don't worry about copying them down now. As we get to them, we'll explain them, because there's nothing worse than learning definitions out of context. So let's make sure that we attach a context to each of these terms. All right, are you ready now to proceed to the introduction, just where we make sure that we are all on the same page as far as what environmental studies is all about? So, environmental studies is the study, of the environment. What gave that away? It's the living things in the environment and the way the living things interact with each other, as well as with non-living things in the environment. And we are going to be focusing on a particular concept within environmental studies known as population ecology. And this is the way populations are going to function or work in that particular environment. So we're going to be going through a set of terms in order to unpack these terms relating to populations. You're going to take a little bit of a break now, and if you haven't already got a piece of paper and a pen to make some notes, take this opportunity of going and getting something, and I'll see you in a little bit. Welcome back, everyone, and let's now get into the nuts and bolts of this lesson. So the first term or keyword that we're going to explain and make sure you know is species. So here's my little friend, the meerkat, and he or she is an individual member of this particular species. Now, how do we know what a species means? What does this word species imply? Because we use it very freely in our everyday language, but it has a very specific biological meaning. So what do we mean? First of all, they must be able to recognize each other as mates. One meerkat must be able to look at another meerkat and recognize each other as potential mates. More importantly, once they've mated, they must be able to interbreed and produce fertile offspring. That's very important to our definition. They mustn't only be able to produce offspring, but those offspring themselves must be able to go on to produce more offspring. So that's what we mean by a species. But what happens if we start putting lots of members of the same species together? Well, simple. That is called a population. So here we've got our little meerkat and all of his or her friends, and they can mate and they can produce offspring. And we call them a population. So they are members of the same species. We know because they're the same species, they have the potential to interbreed, but here is something extra we're adding to our definition of population. The individuals of the species must live in the same area in order for it to be defined as a population. So we can't talk about the population of meerkats, say, in the Kruger Park, and the population of meerkats in, say, Addo Elephant Park as the same population. They might be the same species, but they don't have the potential to interbreed because they live thousands of kilometers apart. So we refer to them as the same species, but two separate populations. This now becomes important for our investigation into population ecology. We're not looking at all the meerkats in South Africa. We're looking only at a group of meerkats that live in the same area with the potential to interbreed. Let's now focus on our next term. So what then is a community? Well, if you have a look at this picture, you'll see there are our meerkats. That's our meerkat population. But now we have a population of giraffe. We have a population of acacia trees. We have a population of elephant. So a community is many populations. But here's the kicker. It must be in the same area. So the species, collection of the species in the same area, population. Collection of different populations in the same area, that's our community. But we need to go one step further. So what is that? That is talking about an ecosystem. Now you can see here's our population of meerkats. Here's a population of wildebeest. Here we've got a population of acacia trees. So we've got many different communities, but we're adding in the water. We're adding in the stones. We're looking at the fact that there's sunlight, there's soil. There are abiotic factors as well, or non-living factors. So once we add our communities and our abiotic factors in that particular area, we are now looking at an ecosystem. So when we talk about environmental studies, we could be talking about a whole range of different concepts. But for this section of work, we're focusing on population ecology, populations and how they change in a particular ecosystem. So I hope we've cleared up some of the terminology for you. This is a bit of previous knowledge that you should have, but at least now you've got a good foundation for moving forward into the new work that we're going to cover. So here's where we were. We've done our little introduction. What we now need to say is we are focusing on populations, and we're going to move on to this first subtopic called parameters. So before we even start with the biology, what do we mean by a parameter? Let's have a look. Parameters are characteristics or properties. And in this case, we're looking at characteristics or properties of a population. All right? So we're not looking at the word in its everyday English meaning, we're looking at the word as it applies to populations. And there are a variety of different parameters we are going to have to become familiar with. So out comes that piece of paper again, because we're back to our keywords. We need to now investigate what each of these parameters is all about. Are you ready? Let's start with our first one. We're going to go to our very first one, which is called density. Now, you might be familiar with the everyday use of the word density. If I talk to you about hand cream is denser than water, you get the idea that hand cream is thicker than water. Hand cream will float on water. Let's now look at what we mean about density in terms of populations. So here we're referring to the number of individuals in a particular area, if we're talking about a population that is on land, or per unit volume. Here, if we're talking about a population that's living in an aquatic environment or ecosystem. So have a look up there at that little graphic. Here we can clearly see that something is less dense and something else is more dense. Right? So the idea of more individuals means that the density is greater, less individuals, the density is less. So we can see that if this, for example, was our population number 1, and this is our population number 2 in a different area, we would see that population 2 is definitely denser than population 1. So it all comes down to how many individuals are we fitting into that particular given space. Because remember, populations are all about the individuals in a particular area. Let's move on now to natality. The word natal refers to birth. So when we talk about natality in terms of life sciences and populations, we're talking about the ratio of the number of births to the size of the population as a whole. So we could call it maybe the birth rate. It's the rate at which new little individuals are being added to the population, of course, by reproduction. So it must be adding to the population size, and it has to be by the process of reproduction. Let's now move on to what I would say is the opposite of natality, which is mortality. Do you know what that means? Mortality is the death rate. It's the rate at which our individuals are dying in that population over a period of time. So do you see why I talk about natality and mortality as kind of being opposites of each other? We're adding to a population with birth, and we're taking away from a population with mortality or death. What about these two terms that look pretty similar? Immigration and emigration. Let's explore these terms. I want you to think about immigration as being in and emigration as being exit. So will you remember the I and the E? That'll help you to remember that when we talk about immigration, we're talking about organisms coming into a population. When we talk about emigration, we're talking about organisms leaving a population. Now, a good example to help you understand this is looking at an elephant population. Because what happens with natural elephant populations is that at times when a young bull becomes sexually mature and is looking for a mate, that bull has to leave or emigrate from that population. It has to leave the population because it's not welcome there by the other reproductive bulls. And that young bull will leave its own population and join a different breeding population, and then it will be immigrating into that population. So immigration is, once again, the rate at which new individuals join the population from elsewhere. Hey guys, let me in. And immigration is go away. We don't need you. Leaving a population to go somewhere else. So it's not dying, but in effect, it's leaving the population. But remember that emigration and immigration are always coupled. We're always going to see that if individuals emigrate from one population, they have to immigrate into another population. So we're going to see this flow that happens between populations. And it is usually all about mates. Too many dominant males will want to get young, reproductively ready males out of their population. And populations that have maybe lost reproductive males because of age and mortality will welcome a younger male into their population. So what we've been looking at here are different parameters, different characteristics of the population. What we now need to go and focus on after parameters, we need now to look at fluctuations. We've looked at parameters of populations. Now we need to look at fluctuations. So this word fluctuations, or for something to fluctuate in English, means to change. So as things happen over time, they fluctuate. And so that same meaning of the word fluctuations can apply in population ecology as well. Question though, how do they change in size? What causes a population to fluctuate in terms of numbers? Let's have a look at the answer. It's going to be these parameters that are going to be key in helping us understand how populations fluctuate or change in size. So we've got our population. Of course, we can increase the size of the population by adding new members of the population due to birth. So natality is going to increase the size of the population. In the same way, immigration or individuals coming from elsewhere will also have the effect of increasing the population size. So we can see that if we're talking about changes in terms of increase, we're looking at the parameters of natality and immigration. And I'm sure you know where we're going next. We can take our population and we can say that some of the members are going to die. And mortality is something that is going to affect the population size. Also, if individuals leave the population due to emigration, this is going to decrease population size. So now what we can do is we can look at the whole concept of how parameters are going to change population size. We're going to have two of our parameters increasing population size, birth rate and immigration, and we're going to have two of our parameters, mortality and immigration, going to decrease the population size. So I hope you can see here, learners, how all of those different parameters we learnt about, just what they meant, their definitions, they all come into play, and we are looking at something called dynamic equilibrium. We're going to come back to this concept again and again, but our population is hardly ever static in terms of size. New individuals are being added. Old individuals are dying. Individuals are moving in and individuals are leaving. And so we're going to see that over time, our population size is going to change. I want you to now go away and have a short break. And when we come back, we're going to be addressing the next part of our lesson on population changing in terms of size. So I'll see you in a bit. Welcome back. We are looking at population changes, and we're going to now move on in our concept map to the concept or the idea of limiting factors. Now, once again, limiting factors, these are terms that you know about from your everyday use of the language. So you've come across limits quite often. If we limit something, we restrict it. We place conditions on it so it can't go further than those limitations. You know, when you write an exam, you've got a time limit. If you are driving a car, you've got a speed limit. If you want to watch something on the movies, sometimes a movie has an age limit, or you might be very lucky in terms of buying an item of clothing that is a limited edition. It's only available for a short while. So everyday language, limit means to control something by restricting it. Let's think now how this applies to populations. In population ecology, there are features called limiting factors that are going to control or limit population growth. They're going to restrict population growth to a particular size, an upper limit or maybe even a lower limit. Let's look at some of these limiting factors, and as we're talking about them, I want you to try and think about natural populations that you may be familiar with think about what is going to naturally limit the size of the population. We can divide our limiting factors into two broad categories. And do you remember earlier on we spoke about the parameter called density? We said that some populations there are fewer individuals, and other populations there are more individuals in the same unit area, and we spoke about the fact that this population is less dense than that population. So we have spoken about the parameter of density, and now we need to link this parameter to the concept of limiting factors. And we can say that limiting factors are either density dependent or density independent. So in other words, what we're saying is the density of the population, the parameter called density, is going to be affected by these limiting factors. So let's talk about this further. Here are a number of key words again, and this is where you've got to be remembering these terms. And we see that we're first going to look at density dependent limiting factors. Food and water. Let's take that as a limiting factor. If we have got an area, let's say a lake or a pond, where there are fish, the fish are going to be controlled, or the population of fish is going to be controlled depending on how much water there is and how much food there is. If our lake starts to dry out in the hot summer months, there's going to be less water available. There's going to be less food available if the food starts dying because of the lack of water. So food and water are definitely factors that are going to limit the population size. If we haven't got enough food, if we haven't got enough water, it means that our population size is probably going to decrease. Of course, if there's plenty food and lots of water, that means that our population will increase in size. What about competition? We're going to look at competition in a number of lessons' time in lots of detail. But I think you understand the idea of competition. Competition means fighting for a limited resource. And if we have got a very dense population, lots of individuals in this particular area, it means that competition is going to be rife. Competition is going to be strong. And that is going to limit the size of the population. What about space and shelter? We're talking here in our set of examples on an aquatic ecosystem. So this poor little fish, inside its bowl, it's got very limited space. And so we can't, in that little artificial ecosystem, put 20 fish because there's not enough space. But of course, if we took this little fish and we put it into a dam or a lake, it's going to have a lot of space and it's going to be able to breed and make more. And there are lots of places for it to find shelter. So space and shelter are important density-dependent limiting factors. What about predation. So what does predation mean? We're also going to explore this factor in a lot more detail, but predation means I eat you. I hunt you, I catch you, and I eat you. I am the predator, you are the prey. Now think about how this is density dependent. If there are lots of hunters or predators and only a few prey species, those predators are going to decrease that prey species population quite significantly. So predation is a very important density-dependent limiting factor. And finally, disease. You know that if we want to restrict the transmission of a disease, we observe social distancing. If we are living in closely packed or dense populations, we're going to see that diseases transmit far easier. So another density-dependent limiting factor is disease. Where we have a very dense population, we're going to see diseases spreading more rapidly. Whereas if there is not a very dense population, if we've got lots of space between the members of the population, we're going to see possibly a decrease in infectious or communicable diseases. So these are our density-dependent limiting factors. What about density-independent factors? Factors that are going to limit a population growth, and they've got nothing to do with how many individuals are in that population. This kind of factor is going to affect populations whether the population is small or whether the population is large and there's overcrowding. It doesn't matter. So something like natural catastrophes, storms, volcanoes and volcanic eruptions, earthquakes, hurricanes, all of these are considered to be natural catastrophes or natural disasters. And quite honestly, if you are a lion in a particular area where there are maybe 10 individuals, or whether you are a lion in an area with 50 individuals, a storm or a flood coming through an area is going to affect your population irrespective of how many members are in that population. So that's why we call them density independent. In the same way, climate changes are going to affect a population irrespective of how many members are in that population. So when we talk about rivers drying up in the summer months, that is density independent. It's going to affect the population irrespective of the size of the population. If we think about snow falling, that's going to stop the growth or cover plants for a particular group of animals to eat, we're going to see that climate is going to affect the populations irrespective of whether that population is dense or large or not so dense and a small population size. Another key word that you need to be familiar with, and that is carrying capacity, and it links to our idea of density. When we talk about the carrying capacity of something, let's once again think of it in terms of normal English. All right? I have 2 hands. That means I can pick up 2 suitcases. Maybe at a push I could shove one under this arm and one there. Oh, maybe I can carry 3. All right, if you help me, you can push another one under this arm. I've got 4, but I've now reached my carrying capacity. I can't carry anything more. Take that idea now into an ecosystem. The carrying capacity of, we're looking at an ecosystem, is the maximum number of individuals of our population that the ecosystem can support. If our ecosystem has 12 trees in it, maybe the carrying capacity of that area is 2 elephants. Introduce another one and another one. It's like me and my suitcases. It's not going to work. The trees are not going to support an increasing population of elephant. And we say that that particular area, that ecosystem, has reached its carrying capacity for elephant. It might be able to have extra lions in the area, but as far as elephants are concerned, it's reached its carrying capacity. So it's linked, this concept of carrying capacity is always linked to the availability of resources. In terms of carrying suitcases, my arms were the resources. In terms of the elephant and food in the population, or food for the elephants, trees are the resources. So if our resources are limited, we're going to find that the carrying capacity of the environment is reached much quicker. Now, relating to carrying capacity, as the population grows, it now starts approaching the carrying capacity, and we see something called environmental resistance coming into the picture, which causes the birth rate or the immigration rate to decrease and the death rate to increase. And of course, we have to leave something good for next time. So I'm not going to deal with environmental resistance in this lesson. We're going to focus on that next time. But eventually, in terms of carrying capacity, there is a balance between adding members to a population and taking away members to from a population, and this number is what we call the carrying capacity of the ecosystem. It's going to be when that population stabilizes at a particular size or number of individuals. Now, let's test what you have learned over the lesson that we've been dealing with right now. Your friend takes this photograph and says, "What a wonderful photo of a population of animals." Now, you don't want to be that friend, but unfortunately, you have learned your life sciences with Mama H, and so therefore you say, sorry, this is not a photograph of a population of animals. I'm so sorry, I love you dearly, but you're wrong. All right? You've now become that friend. But now you can't just tell your friend, dude, you're wrong. You've got to be able to back up your opinions with science. So, explain why your friend is incorrect in calling this group of animals a population. Well, first of all, remember, here's our population of meerkats, But here we've got another population of zebra, a population of wildebeest, a population of acacia trees. So what you've got to tell your friend is that it's not a photograph of a population. I'm so sorry. It's a photograph of a community. Or we've got abiotic factors there as well. We can say, in fact, it's a photograph of an ecosystem. We've got to always help our friends who don't do life sciences. Oh, shame, hey? All right. Next question. This is a notice posted at a beach resort that allows fishing from the beach and the rocks. And the notice says there are closed seasons for certain fish species. The legal size and bag limits are as follows. If you're going to catch a Cape stump nose, the legal size is 20 centimeters and you're only allowed to catch 5. Gr11, 35 centimeters is the legal size. The bag limit, you can only catch 2. But no, Gr11 fishing may be done between the 15th of October and the last day of February in the following year. So my question is, why do you think closed seasons, legal sizes, bag limits are imposed on fishermen? And once again, you need to support your answer with what you know about changes in population sizes. Remember that populations have these parameters. Birth rate, and birth rate or natality is going to increase the size of the population, is going to grow that population. So it makes sense that number one, we do not fish at the time when our particular fish is in fact reproducing. We're also going to make sure that we only catch very mature fish, and we're not going to catch little babies or fish that haven't yet reached their sexual maturity for reproduction. And we're going to limit you in terms of how many you catch so that you don't deplete this particular population due to excessive mortality. This is the kind of question you can expect in exams and in tests. I've put together a little summary for you that you can work through in terms of what we've covered today. We've covered population parameters, limiting factors, carrying capacity, and that means we can cross off population size from our greater scheme of things. And we've got still things to look forward to in upcoming lessons. But from me, Mama H, I'm going to say goodbye to you, but I hope that you're going to make sure that you get our next lesson, because we've got more work to do. We've got more to learn about population sizes. Thank you very much for being with me for this lesson. See you next time. Bye.